Hello, this is John from caveofprogramming.com and welcome to another tutorial on multi-threading in Java from Cave of Programming. And this tutorial is actually on multi-threading in Swing, which has a few peculiarities that we'll go into. And we're going to look at a specialized class in Swing for doing kind of multi-threading stuff. So a lot of the stuff that we've already discussed applies equally well to multi-threading in Swing. If you've got two threads accessing two or more threads accessing a shared resource, then you need to do that via a synchronized method or via a synchronized code block. But what's different in Swing is that you shouldn't have your user interface being updated from threads that you create yourself. Your user interface should only be updated from the main kind of Swing thread, and for that reason the Swing Worker class has been introduced. So let's take a look. I'm just going to run this. This is a little Swing program that I've created, and this is purely, I've got a main program here which is I'm using this Swing utilities to run a Swing thread, and this is kind of the recommended way at the moment of running a Swing program. And then that just creates a new mainframe class, and my mainframe class just extends JFrame, and I've got a couple of labels in here, and I've got a start button. So that looks like this, and if I click this start button at the moment, it does nothing. It just outputs start here in the console using a system.out.println. Now I'm not going to use multiple threads here, I'm just going to use one thread because I want to show you how to use this Swing Worker class. And if I were to put a thread into this program, I guess the place I'd do it in this case, because I'd want it to start when I click the start button, so I'd put that thread somewhere in my main frame class here, which extends JFrame. And maybe I'd have a thread as an instance variable, or I might just create one in this start method here, which is run when the button's clicked. But then I'd have problems if I then wanted to update the user interface, and there are two situations typically where you want to update a user interface from a thread, and one is where you want to get some kind of status from that thread after it's finished, and for that I've created this status label here which I want to update when the thread completes. And you often want to update some kind of progress bar or some label or something while the thread's actually running, and that's the second case, and for that I've created this label up here. And in either case you could have problems in Swing if you try to update the user interface from your running thread. I guess to get a status from the thread you could use a callable and a future, and that wouldn't cause any problems if you then do the update in a main Swing thread. But if you've got a running thread and you're trying to use that to update some label or some progress bar, that could give you some kind of problems even if there's only one thread. And we're going to look at how to solve that now. So in my start method, instead of using the thread class, I'm going to use something called the Swing Worker class. And Swing Worker takes two template arguments, which makes it look highly ferocious, but it's actually not as bad as it first seems. So I'm going to say in start, I'm going to create a Swing Worker, and at the moment I don't want to use either of the kind of template arguments. So I'm going to supply void with a capital V to basically say I don't want to use them. And void with a capital V is kind of the class version of void with a lowercase v, and you can't use void with a lowercase v as a template argument, so you use the class version. It's like the difference between int and integer. So I'm going to say here Swing Worker void void worker, I'll call it, equals new Swing Worker, and I need to supply the template arguments again, unless I'm using Java 7, which I am, but let's assume you might still want to use Java 6. And in Java 7 you could just leave these diamond brackets empty actually, and this is actually an abstract class, so I'm going to implement the abstract method of this class right here with a kind of anonymous class type syntax. So I've said that my worker equals a new swing worker, and then I open a curly parenthesis, close it down here, and in between I can implement the abstract method. Let's add the import with Ctrl-Shift-O, and then I'm going to click this error icon here and go to add unimplemented methods. And this is the one abstract method of swing worker. And notice, by the way, that if you specify void for the template type, this first template type is actually the return value for this doIn background function. And if you have a return type of void with a capital V, you must return null, otherwise you'll get an error. Okay, so let's put the semicolon down here. And now we'll take the simplest case to start with, which is that I just want to run some stuff in its own code, in its own thread. And I don't want to get a return value from it. And I don't want to update the GUI as I go along either. So to do that, I just put stuff in this doIn background method. And let's put some code in here that simulates doing some useful work. So I'll say I equals 0, I less than 30, I plus plus. And let's just have a thread.sleep in here, thread.sleep, maybe 100 milliseconds. And I will also, I'll just have a sysout in here so that we can see that something's happening. Let's just say hello and plus I. Now to actually run this thread, so this is like the public void run version of the method for swing worker. It's kind of the version of the public void run in the thread class. So if this was a thread class, you'd have public void run, and for swing worker you have this doIn background instead. And to execute that, instead of saying worker.start like you do with thread, it's actually worker.execute. And so this whole thing is going to be called, this method is called when I click my start button. So let's click run here and click start, and here we can see that this stuff is running in its own thread. And because it's running in its own thread, the user interface will still be perfectly responsive. It's not going to look up the user interface, which is great. And by the way, I should mention that a swing worker is only kind of a one-shot thing. If you want to be able to, you can stop it by cancelling it, but then if you want to run it again, you actually need a new swing worker. So you can't just run this, wait till it's finished and then run it again. Every time you want to run it, you need to create a new swing worker. But you certainly can cancel it with the cancel method. So this is great. This runs stuff in its own background thread, but there's no way of getting any information out of that thread. And let's suppose now that we want to get a return value from this thread. So we're imagining that this thread's doing some kind of processing here, and we want some kind of status when the processing has finished. Let's say the status could be a, I don't know, like maybe a double value that is the total time taken for processing, or it could be maybe a Boolean value to say that yes, the processing succeeded, or no, it didn't. In fact, let's go with that second option. So to get a return value out of this, and by the way, you can't update, again, you can't update the GUI in this doIn background. It's running in a separate thread, and you shouldn't update your GUI from a separate thread. But we are going to be able to update the GUI nevertheless, as you'll see soon. So to do that, to get a return value, we use this first template argument here, and I'm going to change this to Boolean, and I need to change it here as well. So I'm using Boolean, but this could be anything. It could be a class you made yourself, or an integer, or a double, or whatever you like. As long as it's a class and not a primitive type, then it's fine. And that actually specifies the return value for this doIn background here. So I'm going to change this from void to Boolean, like that. And now how do we actually get the return value here? Well, let's firstly return a value. So I'll say here, return true. And this could be kind of something you'll decide within the logic of your processing. Do we return true or false? Or you could return, as I say, some object of some complex class other than Boolean if you want. Having done that, I'm going to right click and go to source override implement methods, and I'm going to override this done method, and done will be called when the thread finishes. So for the moment, let's just put a sysout in here and say done. So if I run this thread now, so it's going to count up to 30, and then finally we'll get the sysout done, so the done method will be called at the end. And in done you can safely update your user interface. So I can say stuff like, I've got a label called status label, so I can say status label dot set text completed. And if I run this now at the end, task not completed will change to completed, and that's absolutely fine. So you can update the GUI within this done method, but not within doing background. And now to get the return value from doing background, we use the get method. So the return value is a Boolean, so I'll say Boolean status equals, and I'll use get. And get here is going to return a Boolean because that's what I specified for this first template value. So this has to match this, which matches this, and it's also the return value that get will then have. And you can see this throws an exception, so let's just surround this with a try catch. And it throws a couple of exceptions which I'll talk about shortly. But let's use this to get the status, and then I'll paste this in here. And let's just get rid of some blank lines. And let's say completed with status. And let's add on that Boolean value now, status. So we can update the GUI with the value that we've returned here. And I'll run this and click start. And we get true. There we go. But if I return false here, let's say, and click start, then we get false. Now what if I want to have a value that updates my GUI as we go along? So in this processing loop here, this fake processing loop I've created, supposing you want to update a progress bar, or in the case of this application, we're going to update this label here. Again, you can't safely do that from within here, but there is a way of doing it. And we need to use this second template type here. So I'm going to change this to integer just because I'm going to update my GUI with integers, but again you could use any kind of class there, and you could get any kind of object out of this processing as it goes along. And I need to change this to integer. And now when I do my processing in this loop, I can use a method called publish, and I can pass that a value, an integer value, because I've said integer here. So let's pass it I. And again, so just because I'm doing publish here, nothing's going to happen at the moment, and I can't update my GUI here, but what I can do is I can override another method. So I'm going to right click and go to source, override implement methods, and override the process method. And the process method will receive a list of values, and because my second template argument here is an integer, and because integers are what I'm publishing here, this is going to receive a list of integers. The reason it's a list of integers and not a single integer is because this will not be guaranteed to be called every time you do publish. It might save up a bunch of integers and a bunch of these values and give you them all at once in chunks, so to speak. So this could get past 1, 2, 3, 4, 5, 6, then 7, 8, 9 and so on, or not, or it might get past one integer at a time if this loop executes slowly enough. So now I can get the last integer, let's say, from this, which will be the most recent value published, by saying integer int, let's say, value equals chunks.get, and this is just a list, so I'll use get and I'll get the value at chunks.size minus 1, which is the last value in the list, of course. That's just standard Java. And now I can safely update my GUI from within this process method, just like I can from within the done method. So I can say here, I've got a label called count1, and in fact, let's just change that to something a bit more intuitive. I'm just going to refactor this, right click and go to refactor, rename, and I'll change it to count label 1. Not that I have a 2, but I could do. And down here in process now, I'm going to say count label 1.set text, and I'll pass in here, let's say current value and plus I. And now if I run this, we've got a little error there. Let's just save this. Well, let's change this to an integer actually. Integer. And well, I'm doing something wrong, but I'm not sure what. I cannot be resolved. Oh yeah, of course it's value. That was the problem. Okay, value. And yes, int would have worked fine in fact, but this is also good. And let's just run this. And now if I click start, you can see that I'm safely updating this label, and then I get the status at the end. And if you did that using normal threads, then it might well, and often does, throw some kind of exception, or it might not work properly somehow. So that's more or less it for this tutorial. There are other things you can do with Swing Worker. I'm just going to mention very quickly a few little other kind of facets of this whole business. One thing is that you can throw an exception from doing background, because you see it throws exceptions, so you can throw any kind of exception, since this is the parent class of all exceptions. And that would then be wrapped with an execution exception, and you could catch it down here. Also, if you interrupt your thread while it's running by calling worker.cancel, then you would get a, in this case, thread.sleep would throw interrupted exception, which will be caught down here. But as in normal multi-threading, like this isn't going to stop. If it wasn't for the thread.sleep anyway, this wouldn't stop just because you tried to cancel the thread. At least as far as I know it wouldn't. You would have to manually check with is interrupted, I think it is, or something like that, is cancelled, I can't remember. I'm not completely sure about that actually, but the main point is that it could also throw a interrupted exception if you interrupt it while it's running. And then finally, if you do want to use ordinary threads, you can, but as I say, if you've got 2 or more threads that update the same value, you need to do that through a method. A method needs to do the updating, and you need to make the method synchronized or something like that. And if you update the GUI from a running thread, you can do it, but you actually need to pass the you actually need to use swing utilities.invoke later, pass it a class that implements runnable, and in your run code there you can then update your GUI thread. So you could have something that looks a bit like this, although not with a new main frame of course, but you could have this kind of code within a running thread, and you could update your GUI safely from within there, because invoke later actually runs stuff on the main Swing GUI thread. So it is possible to use normal thread classes in Swing, but it's generally better to use Swing Worker, because as you can see it handles a lot of different cases for you. Okay, so that's more than enough for this tutorial, and until next time. Oh, I should say that you can find this code on caveofprogramming.com, and also on there you can find details about other Java courses and video tutorials on stuff like Android and servlet programming and lots of Swing stuff, as well as basic Java. So until next time, happy coding.